In this video, I'm going to talk about data flow diagrams in relation to the development of your data-driven web application that you're probably currently working on. So data flow diagrams show how data flows through a system and between its various entities, processes, and data stores, but they don't show how data is organized within those data stores. So data stores, we're talking about databases and database tables, obviously, as you probably already know. I won't go through the rules for creating data flow diagrams at the moment, and also probably won't spend any time talking about the symbols and what they represent right now for the sake of the length of this video. And you can see here, we've got a whole list of requirements that our data-driven solution must fulfill. Essentially, you've got to create a data flow diagram for each of these points here. Some you'll be able to combine, but I think to get the level of detail and the level of understanding you'll need to develop your algorithms, which come from developing your data flow diagrams, typically you'll need to do one for each. In this video, I'm going to demonstrate the validating HTML forms using PHP process in the context of the login system. There are some awesome examples in the textbook, like on page 127, which you will be able to get and chuck straight into your assignment. Obviously, you've got to recreate those. You can't take a screenshot of those and put them in your assignment, but they will give you a good idea of how to do some of those, such as creating an account, which you'll see is one of our requirements. Registering account, same thing. So it can be useful when you look at some of these lists of requirements. It can be useful to either visualize how that might work if you don't know how you're going to do that or document that straight away, or you can find a website where you can perhaps test that. So for the login system, for example, I've got my example mentoring portal data-driven solution here. So validating HTML form input basically means checking that the user has entered the data in the form correctly. For example, if I don't enter anything and I press login, you'll see there that it's validating that I've entered anything and giving me an error message and not allowing me to log in because I haven't entered anything. In the case that I do enter a username but get the password wrong, again, it's saying invalid email and or password. So it's a good idea at this point, not only to find out how that works, but also to list what those sub-processes are. So for example, in ours, the first sub-process is that it's validating that user has entered data. And secondly, so what happens in a typical login system is it checks whether the data you've entered, if you've entered any at all, matches what's in the database. So check that data matches database data, if you like. So my data flow diagram for the login system, validating the HTML form for that, is going to be made up of these two processes. Just before I move on, I'll just demonstrate what it does when I get the password right. You can see there it logs in. Anyway, to demonstrate creating this data flow diagram, we'll jump over to draw.io, which is a handy tool for diagrams and more. And you can see there in the top left corner, I've got some rules there for creating data flow diagrams, which we must keep in mind to make sure they're legible and easy to interpret, which is the whole point of them. We've got one external entity, and as you may remember, an external entity is the source or destination of data. It's typically associated with a human or another external system. In most data flow diagrams I've seen, it's a person such as a user. So a square is the symbol for a external entity. In this case, it's our user or our student or administrator logging into our mentoring portal. We need an arrow which demonstrates data flow to one of our processes, the first of which was validating that the user has entered data in our form at all, which I'll just demonstrate quickly again. You can see there, it's validating whether or not I've entered data in the form. If you have an arrow on a data flow diagram, you must also have a description of what that data is. So you're describing what data is flowing between the user and our first process. In this case, it is login data, or lack of login data in the demonstration I just provided. Processes, I usually use rounded rectangles for processes on data flow diagrams. So we'll drag one of those in. You usually have a line separating the description of it from the number of that particular data flow diagram. You need a number for that particular data flow diagram, as it is said. I'll chuck that in up the top. Manually move it down so it's neat. And a description of that process. These usually start with a verb. So in our case, a good verb to use would be validate, because we're validating the login data. Oops. What's going on? Validate login data. And that's our first process. Remember, we've only got that and checking that the data matches the database data. So this first process doesn't connect to a data store. The next one does, however. On my example, you can see there it's outputting a message saying invalid email and or password, and that's going back to me, the user. So there is actually data going back the other way as well. So we need to add that in also with our straight arrow. That's not straight. How do we straighten that up? Let's just do our best here. That looks fine to me. And the message or the data that's going back to the user is the success or failure message, which is a plausible data flow. Okay, so that's our first part of our data flow diagram done. Now we can add in our second sub-process or process. I'm just going to copy and paste that first one just to make life a bit easier, and we'll put that directly below. These two processes should connect to one another, because what happens is our first process is that we validate login data and then we check that that login data exists in the database or is correct with what's in the database. So we'll number this one 1.1 if we can, without deleting the whole thing, and we'll change this to let's just say check login data. The first one is validating the login data in the HTML form. The next one is checking the login data compared to the database, and it's fine probably to leave that as check login data. We need obviously to join those, and as I said before, our arrows or our data flows, which are represented by arrows, need a description of what data is actually flowing. In this case, it's the login data as well. What else needs to happen? We need to check that the login data is matches the database. The typical symbol for a data store, such as our database or our database table, is an open-ended rectangle, as you can see here, which you can access in draw.io under the data flow diagram tab, which I think you have to add by clicking more shapes in the bottom left corner. You usually number or identify that particular data store. This is our first data store, so let's just call it D1, data store 1. Easy. In this case, it's our users table, users. And so data is going to flow from our users table to this check login data process. And that will be existing login data, because we're assuming the user's already created an account for our web application. So let's put in another nice straight arrow, hopefully, to represent the data flowing from our data store. That is existing user account data. This would be the username and password that's stored in our database. So that's looking pretty good so far. However, we haven't said what data needs to get back to the user, which is quite common. So let's say that they've entered the right username, which is obviously in the database, and then they've got the password wrong. It does actually output the same message, but we're not validating the form data in that case. We're actually checking that the login data matches what's in the database. So our success failure message again comes from our second process there, which is check login data. So we'll also need data flowing back to the user, which is our success or failure message once again. I'll just do that with a couple of arrows to make it easier. And once again, that's our success or failure message. And that to me looks pretty good for a data flow diagram for our login system. So let's just put a title at the top, validating login data. I guess you could also add login functionality or login system if you like. And we'll make that a bit larger so we can see it. Bold. And Bob's your uncle. So our final step is to check that our data flow diagram matches the rules for creating those. So firstly, use no more than 7 processes. We haven't used more than 7, we've used 2. Each process must have at least one data flow in, one data flow out. At least we've got that. Every data flow must connect to at least one process. Well, we haven't strictly got that with our success failure message from our check login data process. That goes back to the external entity. However, in the textbook, they do that as well. So I'm not quite sure what they mean by that, and I wouldn't worry too much about that. Every entity must connect to at least one process. Yes, we've done that. Data flows in only one direction. This is typically talking about between processes. So in our example, the data flows from the user from left to right to our validate login data process to our check login data process and then back to the user, and that's in one direction. You could argue that data is flowing in 2 directions, for example, between our user and our first process with our login data and our success or failure message, but I think it's talking about between processes it goes in one direction only. For example, you shouldn't have data flowing back from check login data to validate login data. Do not do that. Data flow labels describe information, not actions, which we've done. Don't use verbs in those data flow labels, basically. Processes numbered according to their level. Yes, we've done that. Process names are usually verbs or start with a verb. We've done that. Data flows, data stores are usually nouns. Users is a noun. We've done that. Excellent. And finally, if you're looking at some of these items of functionality that you need to create and are feeling a little daunted or have absolutely no idea how that works, then I would encourage you, as I demonstrated, I'd encourage you to find a website or see if you can find out how that works somehow or visualize it, which should help you out a lot if your teacher can't.